Okay, the first question wants me to give the definitions of the following words. An angle is a figure formed by two rays sharing a common endpoint. Okay. A circle is the set of all points in a plane that are equidistant from a given point. Okay, a perpendicular line is when two lines form a right angle. A parallel line is coplanar lines that never intersect. A line segment, it consists of two endpoints and all the lines in between. Rigid motion is a transformation that preserves an angle measure. Okay, I have this picture and I need to describe what it is. It is an inscribed circle, because the circle is inside. And it was made by angle bisectors. Number 3 wants me to draw a quick sketch of a perpendicular bisector. So what I would normally be given would be a straight line, and then I'd have two arcs, and then my perpendicular bisector would go between the 2 points on my arc. Okay, if I take a look at number 4, it wants me to figure out what kind of figure this picture is being given to me. This is an equilateral triangle. All the sides are the same. Equilateral triangle. The reason I know all the sides are the same is because AB and BC are rays of the first circle over here. And over here, AC and AB are rays of the circle. Okay. Number 5 wants me to describe each of these kinds of rotations. The first one is, so it starts here, and it goes that way. So it's going clockwise, and it only changed 1 point. One quadrant. So it's 90 degrees clockwise. Clockwise, I can spell. And I can figure out what point they're going through if I connect those. This is through -1, -1. Over here, it's going the opposite direction, so it's counterclockwise. And this time, it's going through here because my A's, I forgot through in both words, in both ones. Okay, over here, this one's going clockwise. And this one is also through through 0, 0. Over here, it's completely, oops, it's off the screen. Over here, it's flipping from one side to, or rotating, because we know they're all rotations. Rotating from one side to the other. So 180 degrees, when it's 180, it doesn't matter which direction, clockwise or counter. And it's around 0, 0 again. Okay. Over here, it wants me to graph the original triangle and then what it looks like after it's reflected over the line y equals -x. So I'm going to start by graphing it. It starts at -3, -4. Then I have -2, +4. And -3, -3, 0. Okay. Then what I want to do is I want to reflect it across the line y equals -x. I graphed one of these wrong. Oh, I got them all right. Never mind. Then what I'm going to do is I labeled them wrong. This one was E. This one was F. Okay, then what I'm going to do is I'm going to draw my line y equals -x. It starts at the center. It goes down 1, over 1. 2. Down 1, over 1. There's my line of reflection. Okay, so then I want to see how far, let's use green. So this E is one diagonal away, so I want my new E to be one diagonal away. My F is up 2 over 1 away, so I want my new F to be up 2 over 1 away. My D is up 3 over 4 away, so I'm going to go up 3 over 4 away for my new one. Then I connect my points, and that's what my new triangle looks like. Okay. This one wants me to write the rule for the translation. This triangle, it started, I'm going to look at my A point. It started here, then it went down 2, left 1. So we always start with x comma y, and then I have the arrow showing me that I'm changing. My x value, wait a second, these squares are counting by 4s. So I went down 4. Nope. I went down 4, left 2. Okay. So I'm gonna have x minus 2 because x is left and right, and then y minus 4 because y is up and down. Okay. On number 8, I need to decide how many rotational symmetries they have and how many lines of symmetries they have. So this triangle, it is an equilateral triangle, so I have rotational symmetry. I can spin it around 3 times because there's 3 points. So I have 360 divided by 3, which will give me 120, 240, and 360. Then I'm going to go ahead and draw all my lines. There's 1, 2, 3. For my square, it can be spun around 4 times. So I'm going to do 360 divided by 4, which gives me 90. And then I get 180, because I'm counting by 90s, 270, 360. Then I want to go through and draw my lines. So I have my diagonal lines for my square, and then I have my vertical and horizontal lines. My pentagon, I have 5. So I'm going to do 360 divided by 5. Gives me 72, 144, 216, 288, and 360. And then my rotational will go through each of the vertices. So I have 5. Over here on my hexagon, I have one that goes through, I'm going to continue in the red pen. So one that goes through each of the sides, and then one that goes through each of the angles. So I end up with 6. For my rotational, I'm going to do 360 divided by 6, which gives me 60, 120, 180, 240, 300, 360. Okay. This one shows me 2 different transformations happening on triangle ABC, and I've got to describe what they are. So I first go from this triangle to this triangle because of the primes. This first step is a reflection over the y-axis. Remember, this one is y and this one is x. Then the second thing that happens is I go from this triangle to this one. So it's just shifting down. I want to look at my B points. So this one is going left 3, down 4. So in its translation, 3 units left, and 4 down. This one wants me to give all of my angle pairs. Vertical angles are opposite each other. So I'm going to have angles 1 and 4. Those are opposite. Then I'm going to have angles 5 and 8. Remember, when they're opposite each other, they're congruent. I'm going to have 3 and 2, or 2 and 3, and 6 and 7. Corresponding angles are in the same spot, so I'm going to have 1 and 5. Helps if I write the number. 2 and 6, or no, let's do my blue ones. 4 and 8. Then I have 2 and 6. And 3 and 7. So vertical angles are across. Corresponding angles are same spot. Consecutive interior means they are both on the inside, on the same side of the transversal. So I'm going to have 2 and 5. And then I'm going to have 4 and 7. Consecutive exteriors is outside, same side. So I have 1 and 6. And 3 and 8. So those ones are outside, same side. Alternate exterior angles are opposite outside. So I have 1 and 8 and 3 and 6. I was writing this here. Alternate interior, similar idea, opposite inside. So I have angles 4 and angle 5, and angles 2 and angle 7. Linear pairs are two angles that make a line. So I have angle 1 and angle 2. I have angle 2 and angle 4. I have angle 4 and angle 3, angle 3, and angle 1. Then over here I also have these ones. I have angle 5 and angle 6. I have angle 6 and angle 8. I have angle 8 and angle 7. And I have angle 7 and angle 5. So these ones make a line. Kiki. Number 11 asks me if measure of angle 1 is 100, what other angles are also 100. So, looking at what I have circled up above, all I need to see is which other ones would also be blue. That would be angles 4, angle 5, and angle 8, because they are all congruent. These ones want me to solve. These are alternate interior angles, so they're congruent. So it's just 84. Over here, these are alternate interior. These ones are corresponding off the screen, of course. So then it would also be the same. These ones are a linear pair. So when it's a linear pair, they add up and equal 180. So I have 5x plus 15 equal, nope, so they add up. Okay, so then I want to start off by combining like terms. I have 5x plus 9x, which gives me 14x. I have 15 plus 11, which gives me 26. And it still equals 180. Then I want to subtract 26 on both sides. I have 14x equals 154. Then I divide both sides by 14, and I get x equals 11. Okay, number 15. These ones are consecutive interior. So these ones, let me write what they do. Okay, so these ones also add to 180. I have 5x plus 15 plus 9x plus 11 equals 180. Then I get the same thing on the other side. I combine my like terms, so I have 14x plus 26 equals 180. I subtract 26 on both sides. I got 14x equals 154. Divide both sides by 14. I get x equals 11. I wrote over my second one. Okay, this one wants me to solve for x, the vertical. So I'm going to set them equal. I have 6x equals 5x plus 10. I subtract 5x on both sides. I get x equals 10. Kiki, stop playing with the ornaments. Then it wants me to find the measure of the angle, so I can plug back in. I'm going to pick this one because it's easier. 6 times 10 gives me 60 degrees. Over here, these are corresponding, so I can set them equal to each other. I wrote over my numbers. That was a good plan. Hold on, let me look at this again. So I have 7x plus 5. Equals 6x plus 13. Okay, then I'm going to subtract 6x on both sides. I get x plus 5 equals 13. I subtract 5 on both sides. I get x equals 8. Then I want to plug back in to find the measure of the angle. Doesn't matter which one I pick. They're both equally as hard. I have 7 times 8, which is 56, plus 5, which equals 61 degrees. Okay. This one wants me to prove, given that the two lines are parallel, that alternate interior angles are congruent. So I'm going to start off with my given. R is parallel to S. Okay. Then I want to pick a pair of corresponding angles. I'm just going to pick A and E. So angle A is congruent to angle E by corresponding angles. When I'm doing this proof, I can assume anything except alternate interior, because that's what I'm trying to prove. Then I can say angle A is congruent to angle D by vertical angles. And now I can say angle D is congruent to angle E by the transitive property. That's what I wanted to prove, so I'm done with this one. Okay, number 19 wants me to prove that the angles in the triangle sum to 180. So I'm going to start off by writing my statements and reasons. I start off with my given, so AC is parallel to BD. That was given. I know that angles 4, 2, and 5 all add up to 180 because definition of a straight line. Because I know these two are parallel, I know angle 4 is congruent to angle 1 by alternate interior angles. I also know the same thing about angles 5 and 3. Then I can use substitution to plug those back in for my original equation. So I can say angle 1 plus angle 2 plus angle 3 equals 180 by substitution. And that gets me what I wanted to prove, substitution. Okay. On numbers 20 and 21, they want me to solve for x. There are 180 degrees in a triangle. So what I want to do is I want to add up everything and set it equal to 180. So I have 85 plus 63 plus x equals 180. 85 plus 63 is 148. Then I subtract both sides by 148. I get x equals 32. Over here, remember this square means 90 degrees. So I have 2x plus 3x plus 5 plus 90 equals 180. I want to combine like terms, so I have these two that go together. I have 5x, and then those two go together. Plus 95 equals 180. I want to subtract 95 on both sides. So I have 5x equals 85. And then I divide both sides by 5. I get x equals not 5. Don't know what I was thinking there. It gives me 17. Okay. Given this triangle, I want to name the corresponding part. So measure of angle E is congruent to, I look for the other triangle that also has 2. That would be angle J. This means measure. So I need to know how much angle E was. It's 54 degrees. JI is congruent, so I'm looking for the one that has the double lines. To EF. Then I actually want to know the measure of JI over here. Anytime I have the equal sign, it's looking for a number. So JI is 10. Measure of angle D, it's the same as K, so I move that over. It's 72. Measure of angle F, I remember that these add up to 180, so I'm going to make fx for now. I have 54 plus 72 plus x equals 180. I combine like terms. I have 126 plus x equals 180. Subtract 126 on both sides. I get x equals Kiki, 54. I'll be right back. Okay. This one's talking about a road crew, and it says that the triangles are they're trying to figure out what the width of the oil spill is. Or not the oil spill, the sinkhole. I know the two sides are congruent, 13 and 13, 15 and 15, and then I also know by vertical angles that it's congruent right there. So I know by side angles, they're congruent. And then it's also asking for the length of the oil spill, which is 18 feet. Okay. This one wants me to decide if each of the current triangles are congruent, and if so, how they are. So this one gives me a congruent side. Then I know this is congruent. I don't know if there's the third side or an angle, so this one is not enough information. Over here, I have a congruent side, a congruent angle, and another congruent side. Because these congruent angles are right, they are hypotenuse leg. Over here, I have a side, an angle, and this side by reflexive property. So this one is side angle side. Over here, it gives me two labeled sides, and I know the third one by reflexive property. So this one is side, 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 because I have all three sides. Over here, I have two sides and an angle. This one, because it's a right angle, and it's a leg and a hypotenuse, this one is hypotenuse leg. Over here, I have two congruent angles and a congruent side. So this one is angle, angle, side. Over here, I have just a congruent side and angle. That one is not enough information. Over here, I have a congruent side and a congruent angle. Again, not enough information. You okay, Gigi? Again, I have these two. I actually know they're the same height. So, these ones are side angle side. Nope, just kidding. I don't know they're the same height. What was I thinking? I have an angle, a side, and an angle. So these are angle, side, angle. Over here, they share a side, but that's all I know besides this angle. So this one is, again, not enough information. Number 25 gives me a triangle, and it wants me to prove that they are congruent. A triangle. It gives me a picture and tells me to prove that they are congruent. So I have to start off with my givens. I have AB is congruent to CD. And I'm going to go mark that. AD is congruent to CB. Okay, looking at the picture, I can see they share a side. So I'm going to have BD is congruent to DB by the reflexive property, because it's the same line. Then I can say, because I have three sides in common, I can say triangle ABD is congruent to triangle BCD by side, side, side. Okay, over here on 26, gives me this picture. So I start off with my givens. TS is parallel to VW. That one's already marked for me. And then I have TU is congruent to WU. Those ones are also marked. Then I have these two angles by vertical angles because it looks like a bow tie. Angle TUS is congruent to angle VUW, vertical angles. Then this is a transversal, this TW. So I can say angle T is congruent to angle W by alternate interior angles. Now I have an angle aside and an angle, so I can say my triangles are congruent. Triangle TUS is congruent to triangle VUW by angle side angle. Because my last thing is not a triangle that I need to prove, I'm going to have CPCTC for my reason. Because corresponding parts of congruent triangles are congruent. Okay. This one wants me to prove that the base angles on an isosceles triangle are congruent. So I'm going to start off with my statements and my reasons. I can spell reasons. Okay, I have AB is congruent to AC. That was given. Okay, angle BAD is congruent to angle CAD. This is by constructing the angle bisector of BAC. Okay, then I have AD is congruent to AD by reflexive. Then I have triangle BAD is congruent to triangle CAD because I have three pieces of information now. So this is side angle side. And I wanted to prove angle B is congruent to angle C. So I'm not done. I have one more step. And this is by CPCTC. Okay. Over here, it wants me to write the equation of a line that passes through the given point and is parallel. Parallel means, where's it? Same slope. Okay. So remember my equation of a line is y equals mx plus b. This is my xy. My slope is going to be -1 because it's the same. This 3 is not important. So I want to plug in. I have -2 equals -1 times 4 plus b. Then I have -1 times 4, which is -4 plus b. I add 4 to both sides. B equals 2. Now I need to write the whole equation of my new line. So we use M and B for our new line. So I'm going to get y equals -x plus 2 for my parallel. Okay? When it's perpendicular, it's opposite reciprocal. So that means reciprocal. That means I change the sign. And flip fraction. Okay, so this is my x and y. My m this time is going to be opposite the sign, so it's going to be positive, and I flip my fraction, so 3. Well, I have 3 over 1, so that could just be 3. So then I'm going to plug in, so I have negative 1 equals 3 times negative 2 plus b. 3 times negative 2 is negative 6. I add 6 to both sides. I have 5 equals b. So I plug back in with this m. I have y equals 3x plus 5.